The question says, is the absolute value of a times b greater than a squared times b squared? Statements 1 and 2 provide ranges of values for the squares of a and b respectively. In statement 1, we see a squared is between 0 and 1 over 25. In statement 2, b squared is between 0 and 1 over 16. How can we simplify the analysis of this question? Remember that it's always a good idea to try and simplify the question itself, reformulating or rewriting the question in a simpler way. And how can you achieve that? You can achieve that if you put into practice all equivalences or algebraic identities you may know about. So, what are the algebraic identities that we have at hand? Take a look at this. Here, you have that the square root of the square of some algebraic expression x is always the absolute value of x. Well then, if in this equality you raise both sides of the equation to the power of 2, you will get this. So now, what is the result of squaring a square root? Well, you obtain the radicand. So you have that the square of x is the square of the absolute value of x. Now, let's divide both sides of this equality by the absolute value of x, and we would obtain that x squared divided by the absolute value of x will simply be the absolute value of x. So whenever you meet up with an expression with this form, then you can simply replace and simplify the expression, with this. Just the absolute value of the expression x. Now you may say, how can I use this in the question we have originally? Well, you can see that the question here can be rewritten in this way. Is the absolute value of a times b greater than the square of a times b? And then you can rewrite this if we divide both sides of this inequality by positive factor absolute value of a times b. You may rewrite this in this way. Is 1 greater than ab squared divided by the absolute value of ab? Can you now see the pattern? In this expression, we can clearly notice how this resembles this totally. So, what is the square of a times b divided by the absolute value of a times b? This is simply the absolute value of a times b. So, asking whether the absolute value of a times b is greater than a squared times b squared is the same as asking whether the absolute value of a times b is less than positive 1. So this is the question in the end. Let's use this simplified version of the question to analyze our statements. Well, clearly, from statement 1, we can obtain a range of values for a. Why? If we take square roots on both sides of this inequality, we can see that the square root of a squared must be less than the square root of 1 over 25. But this, because of the identity here, it is simply the absolute value of a, while the square root of 1 over 25 is 1 over 5. So we have this range of values for a. Unfortunately, this is not enough to decide whether the absolute value of a times b is less than 1, because we have no clue about what is the absolute value of b, in which range of values that expression moves. So, not sufficient. Statement 1 alone is not sufficient. What about statement 2? Statement 2 leads to obtain, similarly as in statement 1, a range of values for b. This would be true. The square root of b squared is less than the square root of 1 over 16. That is to say, the absolute value of b is less than 1 over 4. But this second statement doesn't contain any possible ideas about the values the absolute value of A can take. So since we don't have any clue here, we cannot conclude anything about the absolute value of the product. So this is not sufficient either. So we come to the point in which we need to combine the two data or the two pieces of information in statements 1 and 2. So what do? We can say that since these two inequalities are true, and we have the possibility to multiply the absolute value of A times the absolute value of B must be less than the product of 1 over 5 times 1 over 4. And as you can see, this leads to concluding that the absolute value of A times B is less than 1 over 20. But since 1 over 20 is always less than 1, then this implies that the absolute value of A times B is a number less than 1. So we have an affirmative answer to the question using the two statements at the same time. The correct answer choice must be option C. Option C, both statements together are sufficient, but neither statement alone is sufficient.